Hi everyone, just wanted to take a minute to talk a little bit about how to find the orthocenter of a triangle using the vertices. Um, so as a reminder, the orthocenter is the point of concurrency of the altitudes of a triangle, where the altitudes of a triangle are kind of what you would traditionally call the height. It would be the distance or the segment from the vertex to the opposite side, and it is perpendicular. All right. So let me just do a quick little sketch here just to make sure we're kind of on the same idea of what it looks like. So, that's not what I wanted. Okay, so we'll put those. Okay, 1, 3. There's my A. Over 3 up 9. There's oopies over here. And then C would be over 10 up 2. So right off the bat, these are, while they're close, they're not quite horizontal or perpendicular. I'm sorry, not quite horizontal or vertical. Obviously, with these, you want them to be horizontal or vertical, right? Because you need to find perpendicular lines. Okay, so before I decide which ones to use, let me just look at their slopes so that way I can kind of better make that decision. So let's just look at the slope of AB. So the change in y would be 9 minus 3, which is 6, over 3 minus 1, which is 2. So that would be 3. Okay. The slope of AC, that would be 10 minus 3, which is negative 1, over, I'm sorry, 2 minus 3, which is negative 1, and 10 minus 1, which is 9. So that is negative 1/9, and that actually might not be a bad one because then when we have to find the perpendicular line, um, we will be using the opposite reciprocal. So that would just be 9, which is not terrible. And neither would, negative 1/3. But let's look at the last one. So the last one would be BC. The slope of BC, and what would that be? So that would be the change in y, which would be 2 minus 9, which is negative 7, over 10 minus 3, which is 7, which is actually very nice. So negative 1. Okay, so that one has a slope of negative 1. And we're definitely going to pick that one then, right? Because that would mean that we would have a slope of 1 in our other line. And then we would go through the 0.13, which is kind of the nice point. So then we had to decide between these two. Um, so just from quick inspection, if I look at this, if I had to choose between the two of them, I'm actually going to pick this one because it looks like, well, so that would give me a 9 um, as my perpendicular slope. This one would give me negative 1/3, and I would be plugging in 10/2 as a point, which doesn't nicely interact with 1/3. Right, if I had like 3 and 6, that would be a different discussion point. So I'm going to go with these two. Again, it doesn't matter, it's your choice. Um, but obviously, if we can pick the easier lines, we'll be that much better off. Okay, so let's do the perpendicular slope. So that's just 1, and that would be 9. Let me just make sure I did this. Okay. Yep. So we have 9 and 1, and now we need to talk about what point they would go through. So if it is the perpendicular line from AC, it would go through B. So it would go through the point 3, 9, right? So it has to go through a vertex. This one, BC, it goes through A. Okay, so that would be 1, 3, which is actually pretty nice. So I will do two different setups to find the equations of the line. I'll do for this one, point, I'll do point slope, and then this one I will solve for B. All right, so for the first line, which I'm going to do in pink, point slope would be, y minus 9 equals 9 times x minus 3. Okay, so we'd have y minus 9 equals 9x minus 27. So y equals 9x minus 18. All right, and in this other one, I'm going to do red. I'll do it in red. So this one I'm going to solve for b. So you'd have y equals mx plus b. All right, we know m is 1. And now I'm going to put in the 0.13. So 3 equals 1 plus b equals 2. So you get the line y equals x plus 2. Okay. All right, so I don't care which method you use. Either of them works. This one, I think it's a little bit less like plugging back in personally, but I know you have a lot more experience with this form. Okay, so finally, what do we need to do? We need to find the point of intersection. So I'm going to do that over here. So 9x minus 18 equals x plus 2, right? So if I put this on this side, that'd be 20. So 8x equals 20. So x is going to be equal to 20 over 8. Divided by 4 would be 5/4. 2, sorry, 5/2. Right, because 8 divided by 4 is 2, not 4. And then 20 divided by 4 is 5. Okay, so I have 5/2. And then what I will do is I will plug in here. So y, by the way, you can plug it into either. It's just, why would I plug into that one? Equals 5/2. Now, when this is 5/2, that would be the same thing as 4/2, right? 4/2. So y would equal 9/2. So my centroid would be at my point 5. I'm sorry, not my centroid. My orthocenter would be at my point 5/2. 9/2. Okay, so 5/2 and 9/2, which, let's see, if we kind of did these out, what was that? That was over 1. This is over 3, so it'd be here-ish, which is about right. Yeah, that would be perpendicular. That would be the perpendicular. That would be the perpendicular. Yeah, that's about right. Okay, so ultimately, that is how you find the orthocenter of a triangle. This one probably has the least kind of interesting topics to it outside of being able to find it. It does come up in various constructions and things like that, but there's not like any other special properties where things are half or 2/3 or whatever. So let me know if you have any questions, and have a great day.